Hi class, Mr. H here, going to do the last page in 5.3, page 7, on a couple of applications that you would see in physics that deal with some trigonometric functions. The first one is grade resistance. So the picture is of a car going either up or down a hill. And then we have a formula which has F equal W sine theta, where F is the grade resistance due to gravity. And then W is the weight of the car in pounds, and theta is the angle of the incline. If you're going up, theta is positive, and if you're going downhill, theta is negative. Okay, so number 26, what is the grade resistance of a 2,800 pound car traveling at 0.7 degrees uphill? So I would just apply that formula. So F equals W. W is the weight of the car, which I'll put 2,800, sine of the angle 0.7 degrees. And then it's just about calculating that. So I could jump to my calculator and try that out. So what I would do is clear all that from the last time. Oops, I mean clear here. Just put in 2,800. I could just do it all at once in my calculator. 2,800 times sine of the angle. Make sure you're in degree mode, which we were from the last page, so we should be good. And we get 34.2. Okay, so it said round to the nearest. Let me make sure I'm in the right mode. Yeah, degree, okay. Round to the nearest whole number. The nearest pound would be 34. 34 pounds. Okay, so that's it. The next one, a little different. We can jump back to the handout. Okay, computer going a little slow. We got it. By the way, I do have the answers written out from the segment that we did last time about the calculator work. I never showed that. I was writing them down as we were doing them, but there they are in case you wanted to see them written out on the handout. Okay, so there's that. And then we're on to number 27. Number 27 gives you the weight of the car and then the grade resistance, and you have to find the angle of the grade. Okay. So we have our formula, F equals W sine theta. What do we know? So the F is the grade resistance, that's negative 180. The W is the weight, and then we have sine theta. So here we have to solve this equation for sine theta. Got to use a little algebra here. So I want to isolate the trig function, and I would divide both sides by 2130 first. All right, so maybe just do this little step. Divide out that 2130. That cancels that. All right, and so what I end up with is negative 180 divided by 2130 equals sine theta. And I didn't calculate that yet. I'll just do it all at once in my calculator. So this is kind of going back to a problem like these, right? Where you have sine theta equal a number. Remember, in order to calculate that, theta is going to be sine inverse of that number, okay? That's how we calculated that one. That's how we're going to calculate this one. So theta is going to equal sine inverse of negative 180 divided by 2130. And the reason I'm not calculating that first, I think it's better just to do all the calculations in the calculator at once to avoid any kind of rounding error. So if you can do that, that's the best. If you do the calculation, carry out a few decimal places so that you don't have your answer off by a tenth or something, which can be frustrating. Okay, so back to the calculator here. What am I doing? I'm doing sine inverse. So that's second sine, and then negative 180 divided by all within the parentheses here, 2130. All right, and then enter. Okay, and then I get my angle, and this one said round to the nearest hundredth, so that would be a negative 4.85 degrees, right? Makes sense that the angle is negative because the grade resistance was negative, which means we're going down, which is a downward angle. Okay, back to the handout, going back and forth here. The last type of problem we'll do is highway curves. So there's a image there. You're really just sticking with this formula. This one is referring to super elevation, which is the elevation when you have a turn on a highway so that the car stays on the road, right? So the super elevation is this angle. So that's why that image is there. But really, we're just going to apply this formula and plug in the correct numbers. Okay, so this one, if I look at the problem, we have the velocity is 60 feet per second. So in R, we're trying to find the safe radius for the curve. Okay, so that would be the radius here, right? If this is kind of a circle, right? What is that safe radius, which kind of defines the curvature of that road? So R is equal to 60 squared. So I'm looking at that formula. The top is V squared, so that's 60 squared. G is 32.2 right here. Right. Parenthesis F 0.19 plus tangent of theta, which is given as 5 degrees. Okay, so there's what I want to calculate. And again, I can do this all at once into my calculator. Because there's a lot going on in the denominator, I would put an extra set of parentheses around the whole denominator when I type this in. Okay, so I'll show you how I would type it into my calculator all at once to see how it looks. Let's clear this out and start fresh. So I'm going to do 60 squared. There is an x squared button on my calculator. I'll just click that. Divided by, and then I'm going to open a parenthesis for the entire denominator. I'm kind of just typing in how I wrote it down on the handout. 32.2, new open parenthesis, 0.19 plus tangent, which gives me a parenthesis itself, 5. Okay, so there's 3 open parentheses. So I got to close 3 parentheses. 1, 2, 3. And that should do it, and hit enter. Okay. And there is the final answer, 402.9 feet. This says round to the nearest whole number, so that would be a 403. Okay. So I'm writing that down, 403 feet approximately. Okay, so hopefully those help. You'll see some similar problems in your homework. Give them a try. And that's the end of 5.3. Woohoo, we made it. I know that was a lot of video action, but those are some good problems that'll help you with your homework assignments. Again, as always, if you have questions, send them my way. Hope all is well. See you in 5.4. Bye.